Okay. Welcome to the African Plants Georeferencing Train the Trainers workshop. Today, we're going to talk about historical localities and other special cases that appear associated with georeferencing these kind of locations. So to begin, I'm showing you a series of maps. I'm sure you have seen at some point different kinds of maps, in this particular case of Africa or parts of Africa. And we can see that there are maps in different languages. There are maps that come from different dates, maps that may focus on different regions or sections of places. And there are very, very many different maps that we can find. Here, for instance, we have maps of different languages, some that include whole continents, some that includes river sheds, etc. So these are just examples in images of the different kinds of maps that we could find. And so over time, we see that these maps change quite a bit. And that change also depends on who is making the map and their own history, aside from the historical facts around those places. So all the concepts that we're going to, or the ideas I'm going to share today, are things that we need to take into account when we georeference locations. We're going to talk in particular about examples in Africa, but the situations that we're going to mention are common in all the world. In different countries, in different continents, we have problems that are similar. Now, in Africa is particular because it has quite a history of colonialism, and that is going to be a factor that affects the names of the localities and how places are named and referred to over time in quite a marked way, especially in comparison with other places that have not had such a strong history of colonialism. So I'm going to go through examples all over this presentation. And the first one that I'm going to show you is one that is close to me, and I will explain why. When I was little, my grandmother used to play with us, with me and with my siblings, to name countries around the world. She was very keen in geography, and she liked traveling a lot, and so she would teach us the countries, the names of the countries around the world when we were very little. And so we learned the name of those countries from what she was teaching us. And at that time, she knew this country on this map, which is currently the Democratic Republic of Congo. The name that it had back then, and the name that my grandma knew, was Zaire. And Zaire was actually the name of this country for a certain period of time that went from mid-70s to 1997, when it changed to its current name, the Democratic Republic of Congo. Now, I was very little when I learned of this name, Zaire, and it changed to its current name when I was finishing my primary school. So when I got into secondary school, we had a whole year of African geography, and only then I learned that the country had changed its name. Now, that got me thinking that many people who have not had the privilege of having that education or that information in particular about the African countries would probably not know for a long time that the country had changed its name. And so I bring it as an example here to show you how things have changed over time. I'm sure you probably know it much better than I do, but it's a nice example to start this talk. So if I didn't know it had changed its name, my first reaction would be, well, let's look for that name, Zaire, in some gazetteer. And so we can use, for example, Geonames, which is a tool that has a collection of names for places, for countries and provinces, and much smaller places as well. It's a gazetteer. And so what I can do is look in this gazetteer for the name Zaire. And that's what I did. And when I looked for it in Geonames, I got all this list, which is much longer than you can see on the screen. It keeps going down, of places that have Zaire as some related name for the given place. Since I know, or I knew it referred to a country, I kept scrolling down, and at some point down, I found that indeed Zaire was applied at some point in time to a country, and that country is the Democratic Republic of Congo. So if we go to look into this record, Democratic Republic of Congo, we will find its current limits, extent, where the country is, what the country is. And we can explore the different names that this country has been given. And so when we explore those alternate names, we get a list like this one on the right, which has a lot of different names in different languages, and some of them are historical. So all these little clocks here mean that those names are historical in different languages. So let me zoom into this part right here, and here we can find that name Zaire that was applied in different languages to the Democratic Republic of Congo at some point in time. So here I find in Spanish that was the name at some point in time. But what is interesting also here is that aside from having been called Zaire, there were other names as well. So for instance, it was the Belgian Congo at some point when it was under the occupation from Belgium. And so here we can get other types of historical information that will be super important, because we might find locality strings, locality descriptions that can have any of these names, depending on when it was recorded. So we would have to know that, well, the Belgian Congo, what is now the Democratic Republic of Congo, and that country was at some point called with some other names. And so here we have different languages, we have historical patterns, and we have, well, issues that appear that we're going to go into details with more examples after. So this is just a kicker to get us going. And as I was mentioning before, we can identify for historical localities, or in general for any location over time, a series of issues that we will face when we try to georeference. One of the issues that we've been mentioned is the synonymy. And this synonymy can come from different languages. That means in French, we name it in a particular way, and in Spanish in other, and in Afrikaans in other, it has another name. And also from historical processes. Well, aside from this synonymy, we also have other issues that have to do with the changes in shape and in size of the different locations. And so we will have splits, for example, a given province might be split in 2 or more provinces over time, or lumps, which is the opposite, 2 provinces that become 1, for example. We have growth of places, particularly of cities, and we also have movement. And in here in movement, we're going to see examples of movement, but one of the typical examples are rivers, for instance, that change their course over time. And then another set of issues have to do with knowledge gaps. And knowledge gaps can be related to local knowledge, meaning that there might be a lot of knowledge in a particular place about that place, but that knowledge does not reach other spheres. There is also sometimes complete lack of knowledge. And there is also the issue of hidden information. And this can be for many different reasons. We're going to go into each of these topics in particular. So just to remind ourselves to keep in mind while we talk about all these issues, we have discussed before in this course which would be the characteristics of good locality descriptions. So good locality descriptions have to be specific, precise, unequivocal, complete, and accurate. And in here, we have to take into account that what we consider to be precise, specific, unequivocal, etc., now may not be in the future. So, for example, for someone that called the Democratic Republic of Congo Zaire, for them that was pretty specific and precise and unequivocal, because at that time, that was the name of the country. However, for us, now, that name does not apply anymore. And so we have to keep that in mind, because not only the locality descriptions, but the georeferences that we make need to be useful for people in the future. So it's going to be very, very important that we keep this temporal change in mind when we georeference and then when we share the data. So let's go a little bit more into the synonymy issue with respect to languages and historical processes. So with respect to languages, these on the screen are 2 maps that show. The first one on the left shows families of languages that are in Africa. Now, careful, because as it says at the bottom of the map, this map is showing less than 20% of all the languages that are actually in Africa. But this serves us to see all the variation that we can find. And this is important for locations, because in different languages, locations may have different denominations, different names. Now, on the right of the screen, we have the official languages by country, by current countries. And we can see, well, that the languages are much less, the official ones, but still, for some countries, there are 2 or 3 official languages. So even if we went for, let's name the places with their official names right now, we still have more than one option in most cases. And so one example of this is this island that is called Isla de Bioko in Spanish. This island has been under colonization from the Portuguese first, and then they pass it to the Spanish. This island is off the coast of Guinea. And we can see here different alternative names that it has been given. So we have some here that are in Portuguese. We have the English version of the Portuguese name, and we have the Spanish name for it. And so we can see that the island is exactly the same island. We're referring to the same place, but we can have different names for it. And some of them are pretty different. Fernão do Po and Isla de Bioko are pretty different. As we were mentioning before, one big issue that we find when we're trying to deal with African localities is that Africa has gone under several processes of colonialism, and so places have been under the influence of different colonial countries over time. So what we have here on screen is a progression from the 1800s until 1923, and we can see different countries that have dominated different areas in Africa. And we can see that that has changed over time. And so, for example, here we can see quite a change. This is part of the French Congo here, and it has changed quite a bit over time. And if we move it forward in time, here are other maps that go from 1914 to 1947. We can see that the changes have been quite obvious. And again, this has the implication that the names of the places could have changed over time quite a bit, and that the names that we give to a particular area are not the same over time. So for example, here in 1914, all of this space was called Cameroon, but then it got divided up over time. And so we're going to find this very, very often when we're dealing with the African localities. Now we're going to see some examples of splits and lumps and growth and movement. And for splits, I'm going to go back to the Democratic Republic of Congo. And I'm going to show you here a table that has the administrative divisions of DRC over time. So up here, you have from 1908 to 2015. And you can see that it was divided in districts and later in provinces, but in different amount of provinces. And that kept changing over time. And so what was called one name before now is called another name. And some of those divisions include larger or smaller portions of territory. And so one clear example of that is here. In 1908, there was a district called Equator, and that district, together with others, became a province that was called exactly the same, but now this Equator is not the same territory as this Equator was describing. And later on, that got another name, but excluding one of the previous districts. Then it went back to be called Equator, but check this out. So this one is different from this one in that it doesn't include this district, the Lac Leopold II. And that was over a period of 30 years. Then this got further divided, then it went back to the previous name, and then it got divided yet again. So this in 2015 is closer to our time. Equator became a separate province, but that is much smaller even than the first district that was called Equator. So this is to show you that if we had a locality that said Equator Congo or Equator Belgian Congo or Equator Zaire or Equator Democratic Republic of Congo, it would be really difficult to understand which is the territory that this is actually talking about. Because it could be just this piece, or it could include, in the largest case, all of these previous districts, which are now something different, called differently. So this is a clear example of split and lumps with respect to the names of geographic entities or geographic administrative divisions in this case. Now we're going to see an example of growth. Growth is typically more evident in cities, in towns and cities. And so we have here images from Google Earth from different times. So the first one is 1984, then 1991, 2000 and up to 2020. So here in the middle of those images is the Kumasi in Ghana. And so we can see in 1994 that it had a particular extent and how over time that has grown quite a bit. And so if we were in 1984 and someone told us, I collected this plant in Kumasi, we would say, well, we could draw a polygon that includes this territory here. Now, if we look at a current map, the territory that we would draw would probably be very different. So it becomes very important to understand these temporal changes. And moreover, before we could tell easily or pseudo-easily the difference between the Kumasi town and all the surrounding towns. Now, nowadays, that limit or those limits are quite more diffuse. So if we don't have other types of information, like, for example, official limits of the Kumasi town, if there are, if those are actually established, it would be difficult for us to say, well, this point, is it Kumasi or is it the next town south? So you can see that growth can be very, very challenging as well. And finally, we have the issue of movement. So in these maps, I show you the distribution according to different authors. Each of these authors suggested a distribution for the Twa populations. So you can see that each author suggests that the Twa people live in completely different areas. The Twa populations are populations that move around, and so that might explain why the authors are not so sure where they actually live. But again, if we had a locality description that said the Twa settlement, for example, or any particular Twa settlement, it would probably be difficult for us to determine where that was. And so that's when it becomes so important that the locality descriptions are accurate, precise, and in the context that they are described. If we are describing a big city, well, we know that it can grow and it will probably not move completely, the city, it will grow outwards. But for entities, feature, or descriptions in general that are subjected to movement, the kind of description that we provide has to account for that movement. And then another example of movement is also from communities that are migrant, or that move around. Particularly, they dedicate, as far as I understand, they dedicate much of their activities to fishing, and they live around the lake Turkana. That's in the limits between Ethiopia, Kenya, and South Sudan. And so they used to move. Here is the Omago River, and they used to move to the lake and from the lake in different times of the year. Now, in this river, they built a dam, and that building of the dam has changed the shape of the lake. And so you can see here that there has been some sedimentary processes that have changed the land that is now available for those people to move onto. And so if we were talking about the places where they have their settlements, over time, the places where they were able to put those settlements are different. So if we were talking specifically about the lake, the georeference would be different. And if we're talking about the settlements also, it would be different due to that movement and also affected by the movement of the lake itself. So these are just examples of splits, lumps, growth, movement, so that we can keep it in mind. Now, the last thing are knowledge gaps, and this touches difficult topics, and topics that include education, topics that include politics, economics, and I'm not going to go into those very deeply, but yes, I'm going to mention that they exist. In many places, the local knowledge is very rich, but doesn't go out of that local dimension. And so it becomes important that if we're not familiar with a particular place, with a particular area, we try to find those local people who have that knowledge. There is also lack of knowledge, and this lack of knowledge also has to do with a lot of things. Of course, now we're in an era where the access to online sources has changed our ability to find information, but still, internet doesn't have everything, and is also very much influenced by those who write that or share that information on the internet. So it's not exempt of subjectivities and also of incompleteness. We're going to see some examples in a moment. And then there is the hidden information, which again can have many different causes, but the net effect is that we cannot find that information and hence use it to georeference and to make the records better. So we have to keep this in mind when we're thinking of historical locations and other difficult locations. And of course, all of these issues are time dependent. And during this course, we have told you already a couple of times that we're not going to georeference based on the dates of the records. However, we need to keep that in mind when we georeference. So, for example, if we find a particular name in a location description, we have to do some research, check if that name has been applied to something else to a different extent over time, and make sure that we account for those time-dependent differences. So we have talked about a lot of problems, and this might be discouraging. And so let's talk about some solutions that we can apply. So one of the solutions is to try to use a diversity of sources. That means look for information wherever you can find information, because everything is going to add to your knowledge and make us make better decisions about the georeferences that we're going to perform. Another one of the solutions is to always try to apply the best practices. Best practices when we capture the data, when we georeference, and when we share those data. Because as I was mentioning before, some things may have been obvious for the person who wrote down the description that are not obvious to us anymore. And the things that we write may be obvious to us now, but maybe difficult to interpret for someone 20 years or 100 years from now. So about general sources, one of the common places to go for information is Wikipedia. So the question is, do we use Wikipedia as a source? Yes or no? Well, and I'm going to show you some examples about Wikipedia, or the use of Wikipedia. I'm going to start with this river, which is the Cubango River or Okavango River. Here you have at the left Google Maps, the Google Maps image, where you can see that they name it Cubango. Same river, you can see the shape. This shape is, you cannot confuse it. It's very, very particular. in Google Earth, that river is called Okavango. So two Google products, we are already seeing differences in the name. Now, this river has a very extended watershed through different countries, and you can see that when we refer to the Okavango or the Cubango River, it's also difficult to understand if we're only referring to the river or to the whole watershed, because it's called the Okavango watershed, etc. Now, if we wanted to learn more or to try to understand better where the Okavango River is, if we should consider just a piece of the river or the whole watershed, we say, well, let's go look for information in Wikipedia. Let's do that. And here I'm showing you the pages in Wikipedia for 3 different languages. There are more, but here I'm showing for English, for Spanish, and for Afrikaans. Okay, let's go take a look at the English one. We have a general description of the Okavango River and a series of titles with information. Here are the contents that talk about flow, flood, sediment transport, history, etc. Okay, we have this information about the Okavango River in Wikipedia. Now we change the language. And all that we have to do in Wikipedia is choose another language. So I choose Spanish, which is my mother language. And for Spanish, we see a completely different page with different images, with different tables here, completely different. And the contents for the Spanish page talk about climate, mammals, birds, and sightseeing in the river. So nothing to do with the English page. So I am missing all this about the flood, the sediments transport, and etc. If I'm looking at the English one, I'm missing about the climate. It's completely different. And if we go to see the Africans page, we see also that it's completely different. It doesn't even have half of the titles of any of the other two. The only thing that we seem to have conserved is this map here that appears in the 3 pages, but even the photos are different. So this is quite a problem, right? Because we're not having the same information just by changing the language. And this is due to how Wikipedia is built, really, because Wikipedia receives input from users all the time. And so the kind of information that is shared might differ from one user to the other. There's also community translation, but then translations may not include certain parts. And so we find differences that are pretty obvious. Let's look at another example. It's more, I would say. Also in Wikipedia, I said, I'm going to look for the administrative divisions of Senegal. Okay, I go to the administrative divisions of Senegal in the English Wikipedia, and I find that Senegal supposedly has 14 regions, 45 departments, and 113 arrondissements and local collectivities. That's what the English page says. Now I go to the French page. And the French page says it has 14 regions, 45 departments, and here we have quite a change. We have 46 communes d'arrondissement, 113 communes de ville, and 370 communautés rurales. Okay, we see the differences between English and French immediately. All that we have is, well, 14 regions and 45 departments. This seems to match. So I went a little further and I said, okay, if we're fine up to here, this is consistent, let's look at the departments and see what they say. And I looked at the departments. Again, in English and in French. So in English, it says that it has 46 departments. So check this out. In the previous one, it said it had 45. And now it's telling me, no, it has 46. it had 45 until 2008, but then they added another one. Okay, so what is this showing me? That even the English pages are not up to date, because this one said 45 and this one says 46. So this one is not updated, this page. Okay, so in this one, we keep going in English. It says, well, now it talks about the next division down, and it says that it has arrondissement and local collectivities and communes. Now, the numbers don't match those that the French were saying, and even the ones that they were saying before. In this page, it said 113, and in here it says 103. So what happened with the other 10? So you see that the problems are severe. Now we go to the French page. The French page previously said it had 45 departments. Here it says it had 45 departments until 2008, and in 2021 they added another one. Okay, this is more consistent between the French and the French versions, but you see what it says here? That this department was added in 2021, and in the English page, it says it was added in 2008. So we also have differences in this kind of things. So if we were to georeference a locality that has this department, Kermassar, and we had the date, we would have to look for the actual official information to see when was this department actually established, because we have information that is completely inconsistent between these pages. And let me remind you that here we're talking about administrative divisions. These are things that are official, that countries establish. I mean, we're not talking about small places lost in the middle of nowhere. We're talking about administrative divisions. So what's the answer to, do we use Wikipedia? Well, the answer is yes, it is useful because it allows us to see a lot of these things, but we have to be hyper careful, because the information that we can find can be very different depending on which page we are looking at within Wikipedia, which language we're using in Wikipedia, etc. So be very careful and don't trust the information. This is a typical thing that we tell kids. Don't trust what you see on the internet, but use it as a tool to be able to look for more information in more specific or more dedicated sources. And also, very important, always document the sources that you're using. And so in this case, if we're writing as our source Wikipedia, it wouldn't be enough. We would have to say Wikipedia in which language and when we looked at it, because people keep contributing, users keep contributing to Wikipedia, so the information or correcting the information that we find may vary over time. So we need more specific sources, and for specific sources, we can go to different kinds of maps and gazetteers and official sources for names. In some countries, those sources are available. In some others are more difficult to access. Here on the screen, you have a list of some resources. There are very many. This is just a couple of examples, in particular about historical maps that have been useful to me in the past. So maybe John can put those links on the chat, or you have them also listed in the bibliography for the course. So we have talked about diversity of sources and how important that is. So the other solution was best practices at all levels of a locality lifetime, let's say, or locality record lifetime. And so just to remind ourselves what are the best practices associated with location information and with georeferencing, those are accuracy, effectiveness, efficiency, reliability, accessibility, transparency, timeliness, relevance, replicability, and adaptability. And so we have to take these concepts into account, these best practices, principles into account when we're dealing with location data and when we're georeferencing. So related to this, always document the sources and the criteria used when we're georeferencing. Try to consider the time factor, and this goes in different dimensions. The dates where the records were recorded, were taken, the dates of the sources we're using, what we were just talking before, and the georeferencing date. When are we performing the georeference? Because the level of knowledge or access to data or availability of maps may be different depending on the date that we're georeferencing, or even the protocols may change. And then always it is better to overestimate uncertainty and not to underestimate it. This is to mean, if we're going to georeference a location and the location, because of how the description is, could be of a given extent or of a larger extent, because the name has been applied to different territories, always take the larger. Why? Because if you take the smaller one and you made a mistake, you may not be georeferencing the actual location that is referred to in the record. And then, super important, always keep the original data intact. You can provide your references, you can correct errors in the records, you can contribute more information to the records, but the original data must remain intact so that anyone in the future can come back and check with the original record, with the original information. So with that, we're finishing this first part of the module. Are there comments or questions? I see some activity on the chat, but I'm not following it. Okay. Okay. So I'm going to stop sharing now. Okay. So this has been our last module presentation. What we're going to do after, for those who have come a little later to the session, we're going to have a break now. And after the break, we're going to come all together. I'm going to share with you some instructions, because we're going to georeference all together. So what we're going to do is we're going to divide ourselves up in different rooms. We're going to assign you to different rooms in Zoom. I'm going to explain that when we come back. And each group, as a group, will have to georeference locations that we're going to give you. That are real locations that are in GBIF. And so the idea is that each group georeferences a location. Every group georeferences the same one. And then we come back together to the main room and compare our result and discuss the results on some concepts, underlying concepts. Then we split up again into rooms to georeference another location, and so on. We're going to see for how many locations we can address. The idea is to have 4 at least locations to reference among all of us. So we're going to do that. Are there any comments, suggestions? Are we all okay with going to a break? Yes.
Okay, thank you, Paula. I want to ask a question about the general information on the schedule. I see in, on the schedule that we will have post courses between August and September. Please, can you tell us more about the post courses, the post class between August and September? It's written in the schedule.
Oh, yes, yes. That thing about post course is a follow-up that, well, we have to, once we have finished the course, we will assess who has reached the minimum level necessary for getting the certificate, and we need to arrange with the coordinators from each country how the georeferencing will proceed, because this course is framed by a project that Town described in our first session. And in that project, the idea is that you will actually georeference records after the fact. So once we have finished the course and we have determined who has been able to complete it and so on, we will meet with the coordinators and decide how each team from each country will continue to work. And so we will be available to support any of you who is georeferencing during those months and after. And we had also left that to see if any of you needs further support. So it's nothing is obligatory then, but it's a time where we will be available. We will not have sessions nor any of that, at least for now. No, nothing. Okay. The course ends next this week, but once you have handed in the exercises from module 5, which are next, what is it, Friday or Saturday? Was it, John, or Thursday? Oh, the next deadline. But our last class is going to be Friday's Q&A for this course. And then it's just follow up with respect to the project for those of you who are going to georeference within the project.
Okay, unfortunately for me, I cannot attend the two last session because I need to go to Panama for another annual workshop with Smithsonian CTFS. I can attend.
Yeah, I've read that.
Yeah, I can attend via YouTube. Maybe the last session, if I have a small time in Panama, I can attend. Okay, thank you.
Sure. Other questions? Should we go to a break? Yes, no?
No question from my side.
Thanks, Tajin. Okay, we're going to go into a break then, and we'll be back in 10 minutes and start working in groups. So see you all in 10 minutes. Share my screen. Let me know if you can see it. Okay. So we're going to move now to the last bit of this workshop, which is the integration of all the concepts and processes and protocols that we have been exploring during these weeks. So what we're going to do, this is the logistics part, is we're going to have 4 different rooms. And here it says 4 breakout rooms, so we're going to make 3 and plus the main room, which is this one where we are now. We're going to divide all of you into groups, and each group will georeference some locations. We're going to georeference the same location at the same time, and then we're going to come back together to the main room to compare the results. We'll do that for one location, and then we will do it again for another one, and so on. So we will iterate, hopefully through 4 locations. If we have time, we can look at more. So what I'm showing here is a table with some locations that we have chosen from real locations that appear in GBIF associated with biodiversity records. And so we're going to choose some of these to start. And those are going to be the 4 that are selected on the screen. I will put them in here. And so the idea is that we will take, for instance, the first one, and we will georeference that first location record. Don't pay attention to the first column. This is just a number that we have assigned to these locations for tracking them during this session. So it has no meaning at all. We have a column for country code, a column for state province, a column for locality, and one for elevation in meters. Some of the locations will have information in some of these fields, some may not. For instance, the first one doesn't have elevation information, but for each one, you have to take all the information that you have here and try to georeference that location. So I'm going to go back here and ask you to write this down, but to give a general idea of what we expect from you, from each group. We will want you to tell us which locality type the location is, which is the reference feature that you would use to do georeference, if there is any. If there is any feature that you use as a reference, the feature extent, more or less, it doesn't have to be exact, but more or less the extent. And then the georeference, the minimum georeference. And here a clarification, just in case. A minimum georeference has to have the coordinates, latitude and longitude, the datum, and the coordinate uncertainty in meters. So those are the 3 components of a minimum best practice georeference: coordinates, datum, and uncertainty. And on top of that, we will ask you to tell us which sources you use when you try to georeference this, and if you have any remote. Like, for example, we couldn't do this because of X reason, or this location we had to georeference it in this way or this other way. You don't have to write it down, but you have to be able to tell us so that we can compare the different groups and discuss it all together. So we're going to ask you, when you are in the different groups, to choose one person from that group that can speak up and can open the microphone when we come back together to tell us all these findings. So again, these are the localities that we're going to reference, the locations. So I will ask you to please write down now the first one, the information in the first one. All of you write it down on your computer, on a piece of paper. We're going to give you a couple of minutes to do that.
I'll copy it into the chat.
Sorry?
I'll copy it into the chat.
Oh, John will copy it into the chat as well. But you will need this information to be able to perform this georeference, to follow this activity. So John has put it on the chat. You can copy it from there. Also, when we go into the different rooms, John and I, we will be jumping from room to room to see if you have questions, what are the difficulties that you find. So the idea is that we will have 15 minutes or so, between 10 and 15 minutes to do each one, because we need to come back together to discuss them. So are the instructions clear? So I will put what we expect from you here. Also write this down, what we're going to ask you for. Does anyone have any questions about what we're going to do? Okay, are we all back here? I believe so. Well, this was quite a tough exercise. Thank you for staying longer. We were hoping to be able to work on more locations, but you see that georeferencing is not that easy. However, I think you have all done a great job in dealing with the tools and trying to find out the best ways. And well, this is a learning process. And so I hope none of you is very frustrated and that this has been a kind of a reality check for everyone. Again, as I said before, this is a real location. I mean, we took it from a data set that is already published in GBIF. So it's not that we're making these locations up difficult on purpose. These are the real cases that you will face when you have to georeference. So it's been very interesting for us to see how you have used different tools differently, but applying the concepts that we have seen. So I want to show you first. John is going to explain this, but I want to give you an idea of where the points, at least the ones that you have shared. I have 2 points from 2 of the groups, and then 3 points from another group where people came to those points separately. So we have 5 points total that I want to share with you. I'm going to show you now. Let me see if you can see my screen. Okay, so those are the coordinates to which different groups or people arrived. We see that there is quite some variation there. And this is very telling, really, because you see that everyone who georeferences will use different criteria to draw the polygons, to understand which is the most specific locality or part of the string to georeference, which are the limits of that, how big that is. And indeed, if we look at the uncertainties that we got, I want to, let me see, I'm going to hide and leave here just coordinates and uncertainties. See the variation that we had on those uncertainties. From 58 meters to 161,000 meters. So it's not just that the coordinate is a little bit off, more to the north, more to the south, but also the extent that we include in that location is pretty variable. And this is interesting, and I think this has to be a lesson for us all, you trainees and us trainers as well. We're always learning together. But well, these are the results that we get. So that you have an idea, I'm going to measure the distance between the most 2 distant points, or more or less. That's 5 kilometers between the centers of the thing that you proposed. 5 kilometers difference. It's just so that you have an idea of how much the different factors can affect, no? Determining the extents, determining the limits, the boundaries of the features that we use as a reference. Okay, I will pass this to John. John, do you want to show? I also pasted some in that presentation that you're going to share, a couple of polygons. I don't know if you want to show them, or I can show them as well just now just to complete what I just said, because I showed you the difference in coordinates and I showed you the difference in extents, and now I can show you the difference in shapes. This is one of the options that I took from one of the georeferences that you did. So this was the drawing of the polygon, and this was the georeference on GeoPic. So this is the polygon that one of the groups suggested. And this is the polygon that other group suggested. So first you can see that the extent is very different, right, between one and the other. And then you can see the shape is also pretty different between one and the other. And therefore the uncertainties that we get, this one is 7,500 meters, this one is 2,000 meters. And also they are placed in different, they are displaced from one another, no? But so that you can see the variation also on the tool, on the map. Okay, I'll stop sharing and let John go through it a little bit.
Okay, you can see my screen and you can hear me?
Yes.
Okay, so we're doing this location 5, country code AO for Angola, a state province, Lunda Norte, and a locality that has been separated by semicolons into 4 different parts. So the way I approach this is to follow these point radius method steps. So the first step would be to separate the location information into its parts. We were doing that by looking at separate fields here. These are higher geographic administrative areas, and here we don't know. We know that it seems to be separated into 4 separate parts: Dundo, Chitato, northeast of Lunda, and then nearest river Luachimo. What I need to do, I've decided that my parts are divided by the semicolon. So I've got 1, 2, 3, 4 parts. So what was the next step? The next step would be to classify the most specific part of the locality. Well, to do that, I need to actually know which is the most specific part of the locality. And to do that, I need to investigate. If I look at this, the first one looks like a geographic feature. Second one looks like a geographic feature. Third one looks like a direction from a geographic feature. And the fourth one is a little difficult to interpret. It looks like it could be either a commentary that all of this other stuff, that the nearest river to it is the Luachimo River. In other words, it's just saying, listen, all this stuff is with reference to that river, but we're not going to use the river as part of the georeference. Another possibility is that this is a commentary being more specific than all of the rest of this. In other words, we find out what Dundo is, we find out what Chitato is, we find out where Lunda is and what it is. And then with all of that, we go to the part of that that is nearest to the river. So there are actually 2 completely different interpretations of this. I'm going to go with the simpler one, which is that nearest river is Luachimo River. It's just commentary, and I won't use that except to confirm that the place really is near the river. So let's go and look at some information that Paula's put together here. On the map on the far right, you can see where she's delineated where the river is. So that's good. It's consistent. It's near something, the rest of the locality. The more specific part of the whole description seems to be Dundo, this town, which on Google Maps has a polygon, both here and here in the satellite view. So that's the shape that Google Maps has given to Dundo. And if you can see here, Dundo is within a municipality called Chitato, which is within the province Lunda Norte, which is inside of the country Angola. So that helps us to decide what's the most specific part. It would be Dundo. The rest is bigger. The northeast of Lunda is another reference. Lunda is another city to the southwest of this. So it's just helping us to orient in case we can't find the rest. So Dundo. Dundo is our most specific feature. That's what we want to georeference. These are the things you were showing. I don't need to do this, right? I can go back and do it my own way, right? So we have seen, I think all of the groups tried different tools, and they found that in GeoPic, there was no polygon, that in Google Earth Pro, there was no polygon, that in Google Maps, there was the polygon we see on the screen now, and that interestingly, in Google Earth Online on the web, there was a polygon. That was a surprise. In any case, we're going to, for demonstration purposes here, use Google Maps polygon and figure out what to do with this locality. So back to the steps of what do we need to do? We've classified and we've determined what the most specific part of the locality was. It is Dundo. Now, we need to define the extents of that feature. Happily, Google Maps did that for us by providing a polygon. Now we need to find the center and radial of Dundo. That's our step 4. To do that, let's go to Google Maps because it was nice enough to give us this polygon. And I'll expand that to as big as I can to do the drawing. That's a little too big for this screen. You able to see this okay? Okay, so we're on Google Maps. So slightly bigger. Okay, we'll make it as big as we can. So remember, step 4 was to find the center and radial of Dundo. On Google Maps, we can try the first step to get our radial by trying to figure out what the furthest 2 points are in the polygon. And I can do that with the tool, which is to right-click and then pick measure distance. That gives us a ruler. This starts with the starting point of the ruler, and then I need to scroll a little bit to do this, because what I think is the farthest point away is either right here or right here. I'm going to pick this one just to see. And it looks like the measurement is 10.73 kilometers. I'm going to test that that's the furthest by dragging the circle to the other option. Oops. Right. Dragging my circle to the other option and see, oh, it's slightly bigger. Okay, so this was actually the furthest distant point from the one on the far side. And just by using my eye, I would say there are no other that are further apart than that. Okay, I have a diameter. Furthermore, I can see that the entirety of my diameter is within the town of Dundo. Lost me, huh?
Yeah, well, for 1 second we lost your audio.
Okay. Can you hear me? Okay. So I have a diameter. My radial should be simple and my center should be simple. The center should be at the middle of this diagonal. Similarly, simple, the radial should be half of that diagonal. It's the midpoint of it. So I can just take the half of 10.75 kilometers, and that should be my radial for Dundo, which I will enter into my geographic calculator. Remember, it should be 10.38. Is that right? Sorry, 5.38. Yes, take note of that for me, and I'll put it in the calculator later. Now, where's the center? We can find that by zooming in on 5.38. Here's 5.5, 5.4, 5.3, 5. Sorry, I'm going the wrong direction. Here's 5.5, 5.4, 5.3. Yes or no? Each one of these, sorry, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divisions for half of a kilometer. So each one of these is 0.05 kilometers. Right. So this is 5.45, 5.4, 5.38 should be right about here.
5.375.
Okay, 5.375. So my center should be right in the middle of this little piece of this little stretch. I'm going to remove my measuring tool and click on the map so that I can get my coordinates. These are the coordinates of the center of Dundo by my calculation. So now I want to take my information to the georeferencing calculator. My georeference is a geographic feature only because we're georeferencing Dundo. Having chosen that, I just follow the steps. I'm using Google Maps later than 2008. My coordinates are in decimal degrees. I will paste them. I have both coordinates in what I'm pasting, so I want to keep just the latitude in the first and just the longitude in the second. My source is Google Maps. The datum is always WGS84 for Google Maps. Now I go to the precision with which I've captured my latitude and longitude from Google Maps, and I can see it's 1, 2, 3, 4, 5, 6 decimal places. The most specific I have here is only 5 decimal places. So for all intents and purposes, my coordinates are exact. I can't get any better than that. So now I go to the radial, which from what Paola was telling me should be 5.375 kilometers. And here my distance units are kilometers. My measurement error is my own personal measurement error on Google Maps. And for that, I use 5 meters when I'm being careful. I wasn't being very careful in this case because I just put the points at the far sides of Dundo without seeing if they actually fell on the polygon when I zoomed in. So I'm going to reduce my accuracy to 20 meters here. This is, let's assume that I actually can measure that and that I did. So I've entered everything that I need to for a geographic feature only calculation. All that's left to do is calculate. And here are my values. So if you want me to copy these into chat and then you could put them into your mapping technique? Would you like to do that? Okay, so I'm going to copy this with the copy button, and I'm going to paste those results into the chat. If I can find the chat, here we go. And then we can see what those look like in comparison with all of the others. So while Paola is working on that, is there any question about the process that I used there? I know it went fast. Any questions at all?
For measurement error, could you please state that again? How you got the 20 kilometers, I think?
Sure. So I'll do that by actually looking at Google Maps. When I did my measurement on Google Maps, let me zoom out. Let me do for, oh, here I have my polygon for Google Maps. So what I did was I opened my map like this, and I used a measurement tool. So I'm making a measurement. Let's just say it's like that. I right-clicked here, started measuring a distance, and then I right-clicked over here to get the other side. And I happen to get the same number here, but the same number to the nearest 0.01 kilometers. In other words, that is to the nearest 10 meters. So I just happened to get the same number, which has a precision of 10 meters, by clicking on the map. Now, if I go in here and look at the polygon very closely on this side, you can see that I didn't hit it. I was off. I was off by that much, which is probably something like 5 meters. If I go to the other side of the polygon and see how well I did, zoom in here. Ooh, I missed it by even more. So I should have been right there. And that's something like 15 meters difference. So my overall measurement error was 20 meters. That's what I wanted to put in the calculator to demonstrate how careful I was being. This 0.02 kilometers reflects my 20 meters of being lazy on Google Maps. Does that answer the question?
Yes, it does. Thank you.
Okay.
One interesting thing, John, is that when you showed the lower part of the polygon in Google Maps, if you can go back to that. At the very bottom of it, you can zoom in. You can see that that polygon is pretty randomly drawn on Google Maps, because why is that polygon going through the middle of a block, not even on a road? Just zoom in a little bit. Just where your point is. Zoom in more. You see that polygon there, where it crosses the highway, it's going in the middle of a block. It's not even on one road or the other. So this is just to say, careful with the polygons on Google Maps. Check if those polygons actually reflect what the location that you're looking for. And if you don't trust the polygons, draw them yourselves on Google Earth or on GeoPic or wherever, because some of the polygons might be close enough, but some others we have seen on Google Maps that are terribly out of what they should be. So careful, always check, don't just blindly trust the polygons on Google Maps. I see a hand up, Bushari.
Yes, I did have the same problems when I wanted to draw my polygons, because the tools that I used didn't give me a polygon, so I have to draw the polygons by myself, and I couldn't come up. My polygon didn't look like what you got from Google Map. So that was really the problem with me, because I couldn't get the same, what can I say, the same result as the other did. So now my question is, if we don't have a polygon from our tools, how can we delimit our polygons if we don't even know the limits of the area we want, the extent of the area we want to calculate? Or I think the polygon is quite difficult to find out how to make it. So what is the easiest way to find out if our polygon is good or not?
That's an excellent Excellent question. Is the most difficult part of all the georeferencing process is delimiting the features. Ideally, if it's a well-known feature, we might find some information online on which are the limits. For instance, when we have cities or big cities, we have information that says, well, the city ends at this street or this other street, and the north limit is that, and the south limit is that, so that can help us. So, but we have to do some research, which of course we didn't have time during this session to do that, but that can be one way. Generally, what we have to do is take some criterion and say, well, for what I see on the map that I have now at this date, etc., I think the feature goes up to here because outside is already parks or is much less densely populated, or because there is a nearby city, and so I take half the distance between the two to put the limit. But those are subjective criteria, and you will find that you have to take those decisions very often when georeferencing. Of course, that will give us different georeferences for each person that does it. And even if we were using the polygons, as we have seen, those polygons were made by someone who took some criterion that we don't know even. It's like, why did they put the line there and not 50 meters outwards? It was the decision of whoever built that polygon. So what is going to be important is that if you have a certain criteria, that you report those criteria in georeference remarks. And so, for example, in georeference remarks, you can say, well, I georeference, and when I determine the extent of the feature, I included this and that, and I did not include this and that. In some cases, some parts of the polygon will be rather irrelevant, because if you do it a little more to the side or less, you have to be trying to consider primarily the longest axis, the longest line within the polygon. Because what happens in the middle, unless you have big concavities, is not going to matter when you draw the circle. So one practical way of looking at it is, okay, if I have a shape that is more or less rounded or more or less elongated, but without many concavities, look at the longest axis that you can find and try to be very careful at the extremes, at the furthest edges, and in the middle you can be less careful, because it's not going to matter when you draw the circle. So that could be one solution, but it's always full of subjectivity, unfortunately, and there's no way to overcome that.
I'd like to demonstrate that with GeoPic, but first I think Beston had his hand raised. If I'm not mistaken. Someone did.
Yes, I have a question. Yeah, can you hear me?
Yes, we can hear you.
All right, I had problems with the previous exercise, but it has to do with the calculator. Yes, after punching in all the values, I was only getting the value. The answer would be the latitude must be a value between -90 in brackets South Pole and 90 North Pole. So I couldn't go further than this. So what would be the problem on that for the previous exercise?
Previous exercise from the modules, or
Yes,
during
from the
this?
module, yes. No, no, not this, but from the modules.
I can show you how that arises. I don't know what you actually entered, but there's several ways that the problem could arise. One easy one is that the number is too big, like this, and I calculate and I get the error message. Another one is that I think that if there's a space or something inside of here, I get the same thing, that's not actually a decimal number. It doesn't know how to interpret that. So that might be what was happening in your case as well.
Okay.
Does that help?
All right. Yeah. I
Okay.
think it answers the
Okay,
question.
so be careful about spaces or anything else. I think also, let me try one other thing. Suppose that you use a comma. Yes, the same thing. It's expecting that it should be
Mhm.
a period.
Okay.
Yeah. It's locale dependent, not necessarily the language chosen on the calculator. Yeah.
All right. Thank
Okay.
you.
Sure, you're welcome. So, okay, I'll leave it to Paula to show what happened with my georeference.
Can you see my screen there? Okay. So here is, this one is John's point, the one he just calculated with the calculator with respect to the others that we got. It's kind of in the middle of it. Yep. And so still, I'm gonna put borders here and roads and stuff. And labels. So there is there appears Dundo here. But so that you see it more clearly. You wanted to show Geopic? Okay.
Can you see my screen again and hear me?
Yeah.
Okay, so what I wanted to do quickly, based on what Paula was talking about, is do a new interpretation with a polygon, actually two of them, with Geopic, and I'll try to do this fairly quickly. So I'm going to draw a polygon. I picked the polygon tool, and my decision is that everything that looks like town, all the way from the far north part of Portugalia to the far reaches in the south down here, everything that looks like deforested area is the town. That's the criteria I'm going to use for drawing. Whether that's a good criteria or not, I don't know. But just so you know what I'm trying to do. Now, I know that I need to be on the side of the river. In here, it looks like it's a mix of town, river, etc. But I'm going to stick with the boundaries that look like town, and I'm going to draw more or less like this. I'm not being careful. You can see that. This is just to give you an idea. And as I finish this, I want to point out one thing that Paula was talking about that might be easy to understand visually. Okay, so there's all of this in here that I'm going to say is not part of the town because it's all forest. But all of this is, and here's another hole. And then I come back out here and I finish up my shape. Okay, so I've drawn what I think is Dundo. And as soon as I'm finished, Geopic gives me the corrected center, which is this point, and the radial, which reaches to the farthest point from there. So you can see that the circle goes all the way outside of the town on this side because the smallest circle that could be drawn around my polygon was on the border and had to be moved from the border, from the center, which was down here. It got moved up to there, and therefore the whole shape got shifted there. That's because of our rule that the corrected center must be in or on the polygon. You can see the difference of this choice of polygon for the town versus what I did quickly with Google Earth, which was all up here. None of the rest of this was part of Dundo. So if I were to do this georeference, I'd put in my name here, and I would put in a remark. I don't need to put Geopic because that's already been added for me by Geopic, but I would say assumed that that Dundo was the I will correctly spell Dundo when I do this. The area on the satellite image where there were buildings. And I would save it like that. So that's my assumption about how I made my polygon. So that's one way to do it. The other thing was I wanted to show what the difference would be, very different, in fact, by first erasing this whole answer and interpreting the original. Remember, it said nearest river Luachimo. What if that meant that it's the part of Dundo nearest the river? What would that be? I would draw my polygon very differently. Here's the river, and I would do something like, say, it's the part of Dundo. Here's this side nearest the river, and then I close it like that. So that's a very different interpretation, and you can see that it's a very different georeference. If I did that, I would have to say that I assumed that nearest river Luachimo means the part of Dundo nearest to the river. And that's how I do that georeference. So that's how to bring in all of my assumptions that would not at all be obvious just from the georeference. So that's what I wanted to show. I see that there's something in the chat. Alexis, did you have a question? I have a question on this exercise we're working on regarding why are you georeferencing? Why am I georeferencing Dundo instead of Chitato? Okay, that's a fair question. Let me do that by doing a quick search on Google Maps. So here's my polygon for Dundo. I'm going to zoom out a little bit to give us some perspective. We're in this upper northeast section here on the map. Now I'm going to look for Chitato, Angola. And Chitato is bigger and contains Dundo. So Chitato was an administrative division in Angola at the level of a municipality, whereas Dundo was smaller still. It was a city or a town inside of the level called a municipality, which takes up this entire geographic region. So my more specific part of the locality description was this, Dundo. Does that answer the question?
The screen is not seeing, it's not displayed.
I'm sorry?
I cannot see the screen. I cannot see the screen because of when you were saying the Dundo is the bigger than Chitanto.
Can you see it right now?
I want to see the screen, how we can display the Dundo.
Okay, are you able to see my screen right now with the polygon for Chitato?
No, I think it is the problem. Is it my problem of internet? I don't know.
Okay. If you can't see it on my screen, what I would recommend that you do is go to Google Maps, do a search for Dundo, and see its polygon. Then zoom out somewhat and do the same search, replacing Dundo with Chitato. When you do that, you'll see a new polygon. And if you fill your screen with that new polygon, you'll see Dundo inside of it as a town.
Oh, okay.
That's why.
Yeah, thank you.
You're welcome. Any other
Yeah,
questions? It looks like there were others. Okay, so we have a question on the polygon one. When I draw a polygon and save it, this one disappears when I open again the file. Which tool are we talking about, Nestor?
Yeah. When I save polygon, but this one disappear when I open again the same file. I don't know why. For example,
Is this with Google Earth?
Google Earth. Yeah.
Paula's going to answer that question.
Okay, so one thing, if you saved it to, you have two ways of saving a polygon on Google Earth. I mean, it can get saved. I'm going to share my screen so that you. Okay, can you see it there? Can anyone confirm?
I need to stop sharing, sorry.
Yes, I can see.
Okay, excellent, thank you. So when you save a polygon, it can be saved in different places. When you build it, it will go to temporary places here. And so if you leave it there, when you close Google Earth, it's going to disappear because that's temporary. That's for the time that you're working on this session on Google Earth. And when you close it, it goes out. If you don't want it to disappear from here, you have to move it from temporary places to some folder in My Places. Another way of doing it is to save it to your computer. And so if you save it to your computer, for example, I have here Polygon D, I can put Save Place As, and I have to choose one destination in my computer. If you do that, when you close it, it might disappear. You can do it from here, from My Places, or from the temporary places. And if you save it to your computer, to be able to see it, you have to come to File, Open, and then search for the polygon. And then you can see it. And make sure when you open it that it's clicked, because sometimes it opens it unclicked. And so if it's not clicked, you're not going to see it. So I hope some of those solutions help you. Otherwise, you will have to share your screen to see what's going on.
Okay. Next. Thank you.
Sure. Okay. No, we have taken 1 hour more than expected. I hope this has been useful. Are there more questions about this exercise that we did today?
I suspect that by what we have seen today, you have a better idea of what questions you will need to ask during the questions and answers periods. Because today was really putting everything we learned into practice. Remember, it was the integration module. And this is really where the theory becomes practice and practice becomes art. Having good knowledge of what tools you can use, how to use those tools, which ones to use first to see if you can get what you need, and which ones to follow up with in case you need further information. Things don't seem consistent, or you don't like the polygons because what's underneath them doesn't seem right. So hopefully for Wednesday, when we convene with the questions and answers, you will have a very good idea of what questions you have because of what you've seen today. What's hard, what process to use, whether we should be going through more examples just like today, continue with the 3 examples we didn't do today. Anything is fair game. Remember, questions and answers are for you to become experts that we hope you become as a result of this course. And thank you for your patience today, for the extra hour.